tabular data. The birth weights to the nearest pound of a sample of 34 babies at a certain hospital are given in the following table, along with the number of babies at each birth weight. Okay, so you can see here, these are the 34 babies here. You have 2 babies that weigh 5 pounds, 9 babies that weigh 6 pounds, 13 babies that weigh 7 pounds, and 10 babies that weigh 8 pounds. So in order to find the mean, you would have to add up all of these numbers. So it would be 5 plus 5 for the 2 babies, and then for the 9 babies, you would have to add 6 plus 6 plus 6 plus 6 plus 6 9 times. And then for the 13 babies, 7 babies weigh 13 pounds. So you would add up 7 plus 7 plus 7 and so forth until you get to 13 of those babies. And then for 10, you would do the same thing. You would say 8 plus 8 plus 8 plus 8 plus 8 till you get to 10. And you would have those 10 times, right? So once you get all those numbers together, then add up all those numbers or multiply them however you want it to do, because clearly if you have 8 babies, you have 10 babies and 8 of them weighed 8 pounds, that would automatically give you 80. It would give you 80 pounds. So you would have to add up all of those numbers and then divide by 34. Once you divide that by 34, then that will give you the mean. The reason you're dividing it by 34 is because you have 34 babies. So that will give you a sum of 6.9 pounds. Approximating the mean of a data set given an histogram. Students at a major university at Southern California are planning a serious housing crunch. Many of the university students say they have to commute too far to school, and university officials should build more housing near campus. The officials' response is to perform a study. The study, reported in the school newspaper, features the following histogram summarizing the commute distance for a sample of 73 students at the university. Based on the histogram, estimate the mean commute distance in miles for the students in the sample. Carry your intermediate computation to at least 4 decimal places and round your answers to at least 1 decimal place. So here you can see, this is the histogram, and you can see here is the commute per distance, and you see some commute 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20, and 20 to 24 miles to school. So they do not give us the exact amount of mileage that the students travel. However, we can just give a midpoint that each student took in order to come up with the answer. So as we can see here, the commute distance from 0 to 4, 21 students drive a distance of 0 to 24 miles. So we can 0 to 4 miles. So we can just say the midpoint is 2 for there. The commute distance of 4 to 8, the frequency is 21, and so we can say the mileage midpoint there, we will say 6. And from 8 to 12 distance in miles, 15 of those students did that, and so we can say a midpoint of 10. 12 to 16 miles, 7 students say that they travel between 12 to 16 miles, and we took the mean of that, or the midpoint, and said 14. 16 to 20 miles, 6 students says they traveled that distance, so the midpoint of that will be 18. And 20 to 24 miles, 3 students said that they travel that distance. So in order to come up with the answer, the easiest thing to do would simply be, you see this problem here is all written out with the multiplication and the fraction you multiply. However, I did mine a little bit differently. You come up with the same response regardless. What I simply did was multiply 2 times 21, 6 times 21, 10 times 15, 14 times 7, 18 times 6, and 22 times 3. When I multiplied all those numbers together and then added the sums, I got 590. And I divided that 590 by 73 because it was 73 students that participated. And then I came up with a sum of 8.1. Actually, it was like 8.08. And so I rounded it to 8.1. Okay, that's how you work that kind of problem. Percentiles. The following are distances in miles traveled to the workplace by 15 employees of a certain hospital. Here are the numbers of the 15 employees of the miles. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here are the distance in miles that the employees travel. Okay, so the first thing we know now that we absolutely have to do before we start this problem is to place the numbers in order from least to greatest. Okay, so we know we have 15 employees. So how this is the formula here that we would work out. We have N plus P over 100. So we have 15 employees, so the N will be 15, and we want to know what number is in the 30th percentile over 100. So if you just put in your calculator 15 times 30 over 100, you will get 4.5. Since 4.5 is not an integer, you will go up to the next number and it will be 5. So we will see what number that's in the 5th position, and that will give us a 30th percentile. So we have 1, 2, 3, 4, 5. So the number is 13. Okay, finding the 75th percentile using method A. Okay, so we would do the same thing. We know we have 15 participants, so we'll put 15 for A. We want to know what's in the 75th percentile, and we'll divide that by 100. So we multiply in your calculator, you would put 15 times 75 over 100, and that will give you 11.25. Since 11.25 is not an integer, you move up to 12, and so the number we have in the 12th place is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that number would be 25. Wait, 1, 2. Right, that number would be 25. Okay, and so the 12th position, namely, is 25. So therefore, the method A and method A, the 30th and 75th percentile for these distances are 13 and 25 miles.